Aloha mai kako. My name is Jessie Perelman. I'm with CIMAR and the NOAA Pacific Islands Fisheries Science Center. And today I'll be talking to you about a new effort to try to understand some of the patterns and trends and catch rates in our local small boat Hawaiʻi fisheries here in Hawaii with Lawaiʻa, with our local fishers. And before I get any further, I want to take a moment to acknowledge and mahalo the folks who've been involved with this effort with us. The ike a mana'o that we've received from our fishing partners has been a really essential part of trying to understand what's going on in these fisheries. And so without them, this really would not be possible. So why focus on small boat pelagic fisheries in Hawaii? Unlike the larger industrial scale longline fisheries, the small boat fisheries in Hawaii are mixed gear fisheries. So they include multiple gear types, largely troll and handline. Handline includes methods like ikashibi and paluahi. And in terms of the total landings of pelagic fish coming into the state, it comprises about 10% of those total landings. So in sort of monetary value, that translates to roughly $13 million in revenue. That's from the 2022 SAFE report, or a little over 3 million pounds of fish landed. And in terms of the breakdown of species caught in this fishery, here is a handful of some of the more commonly known species. Species like mahi-mahi, ono, we've got a'u, so that's blue marlin and striped marlin. We've got aku, and then big eye and yellowfin tunas. And you can see yellowfin do comprise the largest component of catch in this fishery. But in addition to the monetary values of these fisheries, small boat fisheries in Hawaii play a significant role in the culture and traditions of the many people who call Hawaii home. They play a role in food security and the livelihoods of a lot of folks who fish commercially. And to a smaller extent, they're important in recreation and sport. And so the broader goal of this effort is to develop pono science in partnership with the fishing community to better understand some of the patterns of catch trends going on here. And so to kick this all off, we had the opportunity back in May to travel across the state, island to island, and meet with folks in the fishing community to hear from them about what's important to them, what sort of patterns they might be seeing going on. And this was in partnership with multiple agencies, including NOAA, the Department of Aquatic Resources, the Council, just to be able to engage with and talk story with our local fishers. And so from this, we were able to identify Lawaiʻa who were interested in continuing to work with us to better understand catch rate trends for certain species. And so I just want to highlight here that this is a circular process. It's not unidirectional, that our partners are really involved with every step of this process from the beginning to the end. So what quantitative data is available to start exploring patterns in these small boat fisheries? I just want to take a moment to highlight a couple of them here. First, we have the commercial marine license catch reports. So basically everybody who fishes commercially is required to purchase a marine license and report their catch. And so this is sort of regulated and organized by Department of Aquatic Resources, the state of Hawaii. And this gives us data that's resolved both spatially and temporally. So we get sort of a broad idea of where fish are landed, or where fish are caught, and when they're caught. We've also got dealer records, including records that when fish get sold to, for instance, a Honolulu fish auction, which can give us a better idea about some of the size trends in the fish coming in. And then we have the non-commercial catch records, such as the Hawaii MREP system. And while these data are really useful, they represent a subset of surveyed fishers across the state and largely just give us trends through time of the catch rates of different species. So for the purposes of this talk, I'm going to focus on the commercial marine license catch reports because this gives us the biggest volume of data with which to work with to start. But with that comes quite a few data challenges, and I really wanted to take a moment to highlight that because it really influences how we're able to go about doing this work and why it's so important for us to have this partnership with fishers. So as I mentioned, the data is reported spatially, and what you can see here on the top left is, or top right, excuse me, is the reporting grids that the data is reported by fishers. So we have these big different size reporting blocks that tell us generally where the fish are being caught. We've also got hundreds of thousands of records, so a lot of data, a lot of noise, really difficult to QA/QC what's coming in and what's being reported. And with that, we know that not all catch is being reported. So The commercial catch that does get reported only represents a small fraction of all the fish being landed in the state. But with that, we also know that fishers aren't necessarily reporting everything. They might be throwing fish back. They just might not be always reporting them. So there's a lot of noise here. And then finally, one of the biggest hurdles is trying to standardize the effort from this data. So what really constitutes a trip when we look at the number of fish caught per trip? Because a trip might be a couple hours, it might be a day or multiple days. Different gears are used during trips. Boat speed might differ, whether bait is being used or lures, whether buoys are being targeted or not. So a lot of these questions that really are going to influence the effort going into these fisheries data are not clear from the data that we have. And so this is why it's been so important for us to partner with local fishers to hear from them, folks who are out on the water and understanding what's going on in these fisheries. So as it relates to fishing, as I just mentioned, we hear a lot from folks about how sea state and winds influence the accessibility or the catchability of different species. We hear about how fish aggregating devices may or may not be targeted, how gear is used and how it changes over time, and again, how catch and reporting patterns may vary. So the mana'o and ike that we get from talking to our partners helps us make sense and contextualize all of this data. But in addition to that, and what we're really interested in is trying to understand how the environment might be influencing the catch rates of some of these species. So we hear, and these are just a couple of examples of things we've heard from our partners, but we hear a lot about prey and food availability, the influence of moon phase and tides on whether or not fish are present. We hear the importance of ocean currents and ENSO cycles, and different theories about how spawning and migration might play a role in the seasonality of catch rates for different species. So these are just a handful of the species that we're looking at, but with all this information, we really wanted to make sure we're addressing questions that are of interest to our partners, as well as broader interest to the scientific community. So for the rest of this talk, I'm going to focus on a preliminary case study looking at catch rates for mahi-mahi. And so first of all, we want to understand what are the general patterns through space and time that we see in this fishery. So this map on the top left here shows the month-by-month spatial distribution of catch rates for mahi-mahi. And what you'll probably notice is that the catch rates are highest on the windward sides of the island, largely across all months of the year. But what's really striking is when you look at this plot on the bottom left here, and this shows the strong seasonality that we see in catch rates for mahi-mahi across the year. So we see catch rates peak in spring around April and again in November. And we've heard this a lot from our fishing partners. We hear about the seasonality, and we hear a lot of questions about what could be driving that seasonality, whether the fish are leaving the islands and coming back, or whether spawning is, a component of the seasonality. And so that's one of the questions we really wanted to first look into. So where might mahi-mahi be going, or are they leaving at all? And so we're starting to get into this by not just looking at data from the small boat fisheries, but expanding our breadth of information to other fisheries operating in the Central North Pacific. And so this is just a little nod to Justin Suka's talk that will be later this afternoon. But we are looking in these seasonal patterns in the small boat troll fishery to see how they compare to the catch rates of mahi-mahi in both the shallow set and deep set longline fisheries that operate in the North Pacific. But as you can see from these maps in the middle, the spatial footprint of these fisheries is quite different. So at the top, you can see that the shallow set longline fishery operates largely to the north of Hawaii, targeting this transition zone. We've got the small boat fishery that focuses largely within Hawaii's EEZ, so closer to the islands. And then we've got the deep set longline fishery here on the bottom, which has the biggest breadth of footprint, but that has a component that operates south of the islands. So you can kind of think of this as like a south, central, and north footprint of these different fisheries operating in the Central North Pacific. And what's really, really interesting is that when we look at our catch rate models for mahi-mahi from these different fisheries, we see that very clear bimodal peak in seasonality for catch rates across all of these fisheries. But what we notice when we go from south to north is that those peaks, that seasonality, gets closer and closer together as we move north. And so all of this leads to the question of whether mahi-mahi might be migrating north to south across the Central North Pacific. And I think a really great example of this comes from that deep set longline fishery that I mentioned has the greatest the greatest footprint here. So this map here on the left shows a snapshot of mahi-mahi CPUE, or catch rates, in the winter, so January, February. And you can see that the catch rates are highest to the south of Hawaii in the winter, and that corresponds here to that first peak in catch rates. But then when this fishery expands in the summer and it's fishing both to the south and the north of Hawaii, we see that the catch rates for mahi-mahi are highest to the north of the islands, despite the fact that they're still fishing to the south. And this corresponds to that second broader peak in catch rates we see for mahi-mahi. Again, when we go back to these plots about looking at the seasonality of mahi-mahi catch from all three of these fisheries, this might help explain why we see this same seasonal pattern with slight shifts closer and closer in that seasonality as we move from south to north. So from this potential pattern that we see in mahi-mahi catches across these different fisheries, that leads to the question of what could be driving these patterns in catch rates around Hawaii and across the Pacific. And this is something that was looked into back in the 1990s, and it was suggested when, in the early days of the longline fishery, that mahi catch rates were tracking the latitude of the 23-degree isotherm. So now that we have decades more longline and small boat fisheries data to further look into this, what we can see from these plots here on the right is that there does seem to be a really clear pattern emerging with sea surface temperatures and mahi catch rates, in that it appears that the catch rates are highest in that roughly 22 to 26 degree temperature band across all these fisheries. And this leads to a bigger question as to whether mahi might be following those waters in that temperature band, and what might happen in the future as these isotherms shift to the north with changing ocean conditions. So this work is very preliminary, and we're excited to keep exploring what might be going on here with mahi-mahi catch trends in Hawaii. But I wanted to just take a moment to give that example of how we're using both the information from our Hawaiʻi partners and information from these various data sources. And so to wrap up, I just want to highlight that the small boat fisheries here in Hawaii are very important to the culture, the economy, and food security of the islands. And the mana'o and ike that we are receiving from our Hawaiʻi partners is a really essential component to enable any of this work and to really understand what's happening out there on the water. When we look specifically at mahi-mahi, we see that they exhibit a clear seasonal trend in catch rates across multiple Hawaii-based fisheries. And this is suggestive of a potential north-south mahi-mahi migration, leading to this bimodal pattern in seasonal catch rates that could be linked to sea surface temperature. And with that, I'd like to say a big mahalo nui to all of the partners and collaborators who've been involved with this work and the various funding sources. And I'm happy to take any questions.